Hey people, what is happening? I hope you're doing great today. We are on page 224 as we dive into lesson 4.3. You're going to find here in 4.3 your most favorite thing in the world to do.
Y equals mx plus b.
That's right. So we are back to writing an equation from 2 points on a line.
Yes.
I told you it was coming back. I told you not to forget it.
We get to find slope?
We get to find slope, we get to find the y-intercept, and then we get to put it all together. How does that work with scatter plots, though?
This is awesome.
It just doesn't make any sense, but they're gonna bring it all together here for us in example 1. Let's take a listen. Join me. Maybe.
There we go.
Here we go. You gotta hit the button. Now you can join me.
How does a linear model help you to make a prediction? Think about this question during the lesson.
I don't know. How does it,
Michaela is a speed skater and hopes to compete in future Olympic Games.
Okay.
She researched the winning times for the past 50 years. If the trend in faster speeds continues at the same rate, how can she use the information to predict what might be the time to beat in 2026? What relationship might there be between the two measurements?
So guys, this shouldn't be too hard to figure out. What relationship do we see between years and winning times?
It looks like a negative slope.
Yeah, we're going downhill.
Decrease.
So as the years are increasing, the time is decreasing, right? So this would have a negative correlation, okay? So I'm assuming she's gonna, have to skate faster, than previous years if she wants to win the gold. And of course, that's her goal. Okay.
I want the gold.
Gotta have
There
it.
is a strong negative relationship between winning times
Strong.
and
We
years
learned about
after
that before too.
1960. The trend line has a negative slope.
Trend line. We
The
learned
winning
that
time
too.
tends to decrease from year to year.
Mm-hmm.
Our first step is to write an equation for the trend line.
I told you it was coming
In
back.
order to write an equation for the trend line, we need to know the slope of the line and the y-intercept point.
Mhm.
The y-intercept is about 2 4/10.
Oh.
A calculator can help us find the slope. Rise over run is equal to negative 2/10 divided by 15.
Okay. So again, guys, how would we find slope? We would use that y-intercept point, right? 0, 2.4, and then we would pick out another point, and then of course y minus y over x minus x. That's how we would do it.
Use the general formula y is equal to m times x
we know
plus
this.
b,
This isn't anything
where
new.
m is
It's
the
back,
slope
baby.
and b
Guess
is
who's
the
back?
y-intercept. The equation of the trend line is y is equal to negative 134 10,000ths times x plus 2 4/10.
Okay.
Now you can use the equation of the trend line to predict what might be the winning time in 2026.
Good.
To make this prediction, we need to figure out what value of x to substitute into the equation.
Mm-hmm.
What value should we use?
Okay. So guys, a couple things to note here. One,
Select your answer.
is this slope a good number? Oh my gosh, no. Oh my gosh, no, right? But it doesn't matter, right? We have our trend line equation, right? So this is what we talked about the other day. Trend lines are useful, but they're not that great because my trend line is going to be different than yours. But now we have an equation that we can use. So we're trying to figure out what year, right, can we replace X with. Now we can figure out what time that she needs to skate so she can win the gold medal. Okay, so remember, X is years. Now it says years after 1960, right? Well, what Olympics are we shooting for here? We're shooting for the 2026 Olympics. That's coming up faster than you know it, okay? So in 2026, how many years after 1960 is that, right? That's what we have to figure out. Or you can do a little bit of subtraction, because I know all you people out there love to do me some subtraction. No, it's not 2026. No, you can't do that. You can't do that. You can't triple stamp a double stamp.
3986. Add them together.
Yeah, no. Guys, to figure this out, we take 2026 minus that 1960. Of course, we get 66. Go ahead and plop it in there, Mr. Knoll.
They're not all going to be like this.
Bam. No, we'll get
X
some good numbers.
represents
Don't
the
worry.
number of years between 1960 and 2026. So x is 66. Substitute 66 for x.
Now we're going to find out what time we need to get.
Then add. If the trend in faster
Okay.
times continues at the same rate, Michaela should target about 1 and 51/100 minutes,
Okay.
or 1 minute 30 seconds.
You're going to have to pick it up.
She better skate fast.
That's good time.
Yep. Okay. All right. Assuming the trend line shown in the graph continues, use the equation of the trend line to predict fuel consumption, okay, in miles per gallon by 2025. All right. All right. So, folks, we got to come up with some good points here. So, Mr. Knoll's going to zoom in on that graph for me,
You betcha.
and we're going to pick some good points here, my people. Okay. Do we know the y-intercept?
Yeah.
Yes, we do, guys. What?
Looks like it.
I don't know what number is halfway between 12 and 18.
Well, add them together and divide by 2.
15. 15. Okay. So, guys, we're going to use this point here,
Nice.
right?
I like that one.
This is the point 0, 15.
I see a good one. Maybe that one?
Yeah.
Or this one?
Well, I was going to go this one here.
Or you want to go out there?
Yeah, because look, this one has numbers on it already, Mr. Knoll, so it's nice and easy for me.
Okay.
Right? It's 24, 30, right? No. Don't believe everything. Okay, so this one's 30, 24. Now we get to do your most favorite thing, find slope. Okay, y minus y, 24 minus 15 over x minus x, 30 minus 0. Now that's my kind of subtraction problem right there, folks.
I love minus 0.
Yeah, so we're going to say this is 9 over 30. Should we leave it as 9 over 30?
No.
Reduce that, right? We can call that, what, 3 over 10?
3 over 10.
Okay, so we now have a m of 3/10.
Well, we got a B, too.
We got a b of 15. You guys think you can put it all together, write an equation for me? Yeah, you want me to take that call? Who is it? Oh, okay, yeah, we'll do that. All right, guys, hey, we're going to put it all together. Y equals 3/10 x plus 15. Bam. So what can we do with that?
I don't know.
Well, guys, now we can use either of our x or y variables to make predictions. So if they tell me what year, right? If they give me a year, we replace x with that, and then we will know the miles per gallon, right?
Now remember, this is years after 1980.
Yeah, it's years after. Or we can do the opposite. If they want to know, hey, miles per gallon, what year is that going to happen? Then we just replace y with that number, okay? All right, so let's hop back here. The equation for the trend line, we already said it, 3/10 x plus 15. In 2025, so they're giving us a year. So think to yourself, replace x, replace y. Which one are we going to do?
X.
That's right, we're going to do x. Now it says in 2025. So we can't just replace x with 2025, right? We have to figure out how many years after 1980 the year 2025 is. Subtract them, folks. Subtract them. We should get 45. So now we're going to come back over here. We're going to replace x with the number 45.
45.
We're going to do a little bit of multiplying and a little bit of adding. Let's see, that's going to be what, 120, 135, 13 and a half, 28.5?
You have a different trend line. Sorry.
28.5. Mr. Knoll's going to check my mental math.
3/10
Times
times 45 plus 15. 28 and a half.
Okay, there you go. So 28.5, right, is our predicted miles per gallon fuel consumption. Sweet.
That's pretty awesome. 5-car gets better than that.
I don't know that it does. I'm gonna have to say no.
Yeah, it does.
All right, example 2. Here we go. You ready?
Yeah, this one's easy. All we got to do is use a scatter plot to make a prediction.
Yeah.
The scatter plot shows the relationship between the number of people at a water park and the temperature. About how many people should the owners of the park expect at the water park when the temperature is 90 degrees Fahrenheit?
90 degrees.
Definitely a positive relationship between temperature and number of people at a water park.
Absolutely. So positive, linear. What do you guys think? Strong or weak? Strong or weak?
I'll go with strong. I'd say strong.
Yeah, I would say that that's probably the weakest strong we could have. If those dots get any more spread out, we're going to call it weak. But yeah, I think we can agree that that's strong.
Yeah, it's definitely more strong than weak.
Okay. So guys, if we're going to use a trend line to make predictions, right, this is literally all you got to do. Yeah, look, they even drew the line. We go over to whatever value they give me. In this case, it was 90 degrees. We draw a line up to our trend line, not to one of the other dots, but to the trend line, and then we go over to our y-axis, and whatever number is there, hey, that's the number that we're going to use. So at 90 degrees, we would expect to have, it looks like just a little bit more than 800 people at the water park.
Yeah.
Right?
Could you predict for me, Mr. Bricky, how warm it would be for 600 people?
Absolutely.
What do you do?
So if there's 600 people, look, I got to get on this side. So I'm going to go 600. I'm going to go over to my trend line here. Right? Then I'm going to go down, and we're going to see where that meets. Looks right there between 70 and 80. So we'd say it's about 75 degrees. About 75 degrees. So you can use either variable, temperature or number of people, guys, when they give us a trend line, and they're asking us to make predictions.
I like it.
Okay? Again, that's not as accurate as using our trend line equation. We like that one a lot better, though.
Ooh, look at this. Example 3 is a bonus video.
Bonus video!
Oh, yeah.
The scatter plot suggests a linear relationship
I agree with
between
that.
two variables,
Yep.
the temperature and the number of smoothies purchased in thousands.
I like smoothies.
Part A.
Take
What does the
strawberry
rate
mango.
of change or slope represent in this situation?
I'd say.
What is the rate of change or slope? So again, guys, rate of change slope, y over x. So it's this many y's for this many x's. So it's the number of smoothies purchased for the temperature, right? So again, if you think it's number of smoothies purchased for every 1 degree of temperature increase, right?
I like it.
All right, that's what we're after.
The rate of change or slope describes the number of smoothies purchased
just
for
said
each 1 degree of temperature increase.
Gosh, you're on fire.
How can
this
you find
morning.
the slope?
How can you find the slope? You people know that.
I don't know. How do we find slope, people? Duh, yeah. Find two ordered pairs, y minus y over x minus x. You guys know how to do this?
To find the slope, begin by choosing 2 points on the
Why
graph
wouldn't
of
they
the
just
trend
choose
line.
that point there?
You're saying the y-intercept?
Yeah,
That
well,
would be a good one to use.
that'd be a good
The
one.
points with
That's okay, though.
coordinates 40, 32,
Yep.
and 80, 56. The slope is equal to the difference in the y-coordinates of the 2 points divided by the difference in the x-coordinates.
This isn't anything new.
And the
Uh-oh.
fraction simplifies to 24/40ths, or 3/5. Part B. What does the y-intercept
need
of the
those
line
updates.
represent in this situation?
Okay.
What is the y-intercept?
All right, so the y-intercept, guys, we figured out, we've looked very closely at this graph over here. We figured out the y-intercept is
Look at that.
8. We figured out it's 8. Now, what does that mean? What does that mean? Again, so this means at this temperature, we're going to have that many smoothies sold. So at 0 degrees, we will sell 8,000 smoothies. Or you could say it the other way. We're going to sell 8,000 smoothies when it's 0 degrees outside. Okay? So now we're going to have a trend line equation, hopefully, to do some more fun stuff with. Keep
The
playing.
y-intercept of the line represents the number of smoothies sold when the temperature is 0 degrees Fahrenheit.
That's right.
The graph shows that the y-intercept is equal to 8. Part C. What equation relates the temperature, x, and the number of people who buy a smoothie, y?
Well, we know that.
If we know the slope is
Use the
3/5,
slope-intercept form of a linear equation.
the intercept is
y equals
8.
mx
We
plus
should be
b,
pretty good here.
in which m is the slope and b is the y-intercept.
Mm-hmm.
The equation for the line
Put it
is
all
y
together.
equals 3/5 x plus 8.
We are not going to have our turkey bowl this morning.
Oh, no.
Just to make sure we're being extra safe.
Oh, no turkey bowl this morning.
That was the best idea.
Guys, the
What?
guy teachers have won the last 10 years running.
Yeah.
So,
One again this
you
year.
know,
So we'll just say
The female teachers were probably chickening
Yeah.
out.
they were.
on the turkey bowl.
Consolation prize, there are donuts in
Ooh.
room 100 for first floor.
Donuts in room 100. You guys want to go get some with me?
To library for
Well, we're going to finish up this triad here.
Start getting your digestive systems
Yeah,
ready
then we're going to be good to go.
tomorrow with the donut this morning.
Okay.
Have a great day and let other staff know as they're coming in.
Yes, yes, yes. Quit talking, Mr.
A
Monty.
smoothie cafe has the ingredients needed to make 50,000 smoothies on a
50,000!
day when the high temperature is
So-
expected to reach 90
That's a
degrees
lot of
Fahrenheit.
smoothies.
Should the cafe employees expect to have enough ingredients for the day's smoothie sales? Explain.
Well,
I
okay.
think that should be something we want to use our trend line for.
Yes.
Or
I
our
mean,
equation. I mean, you can do a lot of stuff here.
yeah. We can try to use our trend line, right, guys? So we know we have enough stuff for 50,000 smoothies. So we need to locate 50. Okay, so
Oh, here,
Oh,
I'll
boy.
zoom in for you.
okay. Oh yeah, that would be good. Mr. Knowles going to zoom in. So all right, guys. So here we are, 48. Here's 64. Oh no, what number is halfway between them?
Oh, add them together, divided by 2. Oh, dear Lord, 56.
Yeah, this is not okay. So 56, 48 right here. Let me write in 56, and we're looking for 50. I mean, here's where maybe we can't necessarily use our trend line to be really accurate. Like I'm guessing, guys, 50 is probably going to be somewhere right about here, right? So I'm going to assume, right, whatever number's down here, this is going to be 70. I'm going to think we should get an answer pretty close to 70. So if we're using our trend line, that's what we would do. But do we have an equation for this awesome thing?
You betcha.
Yeah, we do. Remember, our slope was 2/3. So here, y equals 2
No,
thirds.
3/5, buddy. 3/5. Oh, they got a slope of 2/3 on this.
They got 2/3, yeah. Plus 8. Hang tight, Mr. Knoll. Okay. All right, so let's see. They said 50,000 smoothies. So is 50,000 smoothies a y variable or an x variable? Which one are we going to replace with not necessarily 50,000, but in this case 50?
Smoothies, y-axis.
Yes, that's the y-axis. So we want to replace this with 50. And now we get to do your most favoritist thing in the world, and that is solve equations, okay? So hey, first thing we're going to do here, subtract 8 from both sides, right? Subtract 8. This is going to turn into 42, right? We know this 8 went away. Don't know. Mr. Knowles not going to give me any help on this. We're going to try to get this one done all by my lonesome here. I'm a very visual math solver, guys, so I've got to put that over there because that's going to make that 21. And 21 times 3 is 63, and that's what we should get. So, bam, 63. So it's 63 degrees out. Okay.
Do we have enough?
Yeah, we still haven't answered the question, though, people, right? And sometimes, look, sometimes this will be enough and this will be our answer, right? But this just says, hey, if it's 63 degrees out, you are going to sell 50,000 smoothies. Now, the question said the temperature is going to reach 90 degrees today. Do we have enough, ingredients for all that day's smoothies?
We need more stuff.
No, we don't. We only have enough stuff for it to be 63. So hopefully a cold front blows through and we ain't got to worry about this, okay? But as it stands right now, we clearly do not have enough smoothie stuff to make smoothies when it's 90 degrees out,
Yeah.
okay? So anyway, guys, that is how we use our trend lines. That is how we use our trend line equations, okay, to make predictions and answer questions, if I can say it. With that, we should be able to hop back into our 4-3 key concepts, right? And then we'll get into our additional practice, all right? I'll see you guys in a little bit.